polynomial degree 4, but I can replace it. So at the core, at the very core, it's really quadratic. If I use x squared to be b, then I change it into a quadratic equation. In core, at the bottom of its heart, it's quadratic actually. But it's really not, because it's polynomial degree 4, and I wrote 4 solutions. There is no quadratic equation with 4 solutions.
So is it like 2 quadratics?
You could consider it, but it's not. You could consider it as 2 quadratics. It turns into 2 quadratics if you want to say that. Yeah. Let's look at another. Okay, what about 48? Same page, 48. X to negative 2 minus x to negative 1 minus 6 equals 0. Can anyone refresh our memory on what is x to negative 1? Excellent, 1 over x. So x to negative 1 is 1 over x because of the following exponential rule. X to negative n is 1 over x to the nth power. Very good. That's the general rule, and this is for x to negative 1. Yes, we can change this equation to a rational equation. We don't want to. Is this equation quadratic in form? I don't know. Which of these two powers should be denoted by a letter? X to negative 1. So give me a letter. Any letter you want other than x. And say it again.
T.
T. Very good. T is a very good one. Because I need to find t squared.
Okay.
If I start with t to x to negative 2 as being t, then I will never be able to find x to negative 1. Yeah, very good question. So what will t squared be then? Perfect. So then the new equation, I replace this. So can I say now that this is quadratic in form for sure? Yes, because I can change it with a quadratic into a quadratic equation. Can anyone dictate? Of course. I cannot use t and x in the same problem. Very good. Excellent. So see, this is a very important concept. Once we move from x to t, x has no place in there at all. When we move from x, we've completely moved to t. Okay, perfect. So this is now a piece of cake. It's a trinomial, it's in descending order, no greatest common factor, no negative leading coefficient, no special product, because negative 6 is not positive and it's not a perfect square. So then 1 as the leading coefficient, and I like that. How do I factor?
T minus 3. T minus 2.
But plus?
2 plus.
Perfect. So there are 2 options for t. T equals?
Negative 30.
Awesome. However, again, I'm just making a point, just a refresher for you. This is not what I'm solving. The first equation, t equals 3, really represents, I have to replace t. I'm not using this. What do I replace t by? X to negative 1. Very good. And the other equation is x to negative 1. Good. So now, what does x to negative 1 represent? Excellent. 1 over x equals 3 over 1. That's one of the exactly. That's one of the reasons why I did that when we saw rational equations, because this is coming up. So how do we call it? How is this called? Very important word to remember, because only in a we can cross multiply. What is it called? proportion. Please remember, only in a proportion we can cross multiply. So then what do you get from here? This product is perfect. This product is very good. So then x equals excellent. Now the second equation. X to negative 1 will be replaced by x to negative 1 will be replaced by perfect, thank you. So 1 over x equals exactly. I think Tony likes this method now. Again, I'm not forcing anyone to change to my method, but it pops up all the time. So now this is a proportion. Again, I have 1, and I have negative 2x, so x must be negative 1/2. So this equation has two solutions, 1/3 and negative 1/2. We did not square. We don't have to go back and check. We did not cube. So everything was legitimate step by step. We just changed it into a quadratic because it was easier to factor. I think we should look at one more. Is that okay? Okay, so let's look at one more. And then there is one more type of equation, and we can move on from that. Okay, so I'm looking at 58. So this is x squared minus 2x squared. Oh, I'm sorry, 186. Minus 11, x squared minus 2x plus 24 equals 0. If you did not know anything about what it's called quadratic equations that are quadratic in form, what would you have done here? Right? You would have squared, you would have distributed, combined like terms, and changed it into a polynomial. But let's use this substitution method if you want, or equations quadratic in form if the equation is quadratic in form. Otherwise, I can't use it. By the way, what is a degree? So it's x squared squared. Yes. How many solutions I expect? Good. So you can say, okay, you say it's quadratic in form. I say it's polynomial. Which one is it? Both. But it's easier not to expand x squared minus 2x and subtract and combine like terms, because you get back to x to the 4th. And that's another situation, right? So now I do see a quantity to which power? What is the power here? 1. And I see the same quantity to which power? 2. So I will, please give me a letter. I will say let equals
X.
Indeed. Very good. X squared minus 2x. Because a squared definitely will be
X squared minus 2x squared.
very good. Excellent. When I get tired, you can teach for me. He answers everything. Awesome. Good. So then this equation is definitely quadratic in form. How do I write it now?
X squared
Yes.
minus 11
Yes.
plus 24.
Yes. Isn't this more human than the original one?
A lot better.
A lot better. Good. So now I know how to factor. It's a trinomial. It's in descending order. No greatest common factor. No negative leading coefficient. No special product, but 1 is the leading coefficient.
X minus 3, X, or A minus 3, A minus 8.
Excellent. So then A equals and A equals. Remember how many solutions we have to come up with?
4.
Very good. Awesome. So A, the options for A are?
3.
Very good. Awesome. But this is not what we are trying to do. A is our invention, right? That was used to show us or lead us on an easy path. But this is not what we're solving for. We're not solving for A. This is just an intermediate step. So then this equation is?
X squared minus 2x equals 3.
Very good. And this equation is?
X squared minus 2x equals 38.
Great job. Thank you. So then now I have two more quadratic equations to deal with. What is the first one? And you can do whatever you want. Of course, not complete the square or take the square root because it's not possible right now in this stage. But you can factor or use the quadratic formula, whatever you want. Nobody's telling you what to do at this point. But of course, you should try factoring because if it takes 10 seconds, why not? Quadratic formula is much longer. So can anyone give us the factor form of any of these two? And then we will have the final answer.
The first one will be x minus 3 and 3x plus 1.
X minus 3x plus 1, very good. And the other one?
X minus 4 plus 2.
Very good. X minus 3, x plus 1, so x equals, and x minus 4, x plus 2, and x equals, and x equals. And we get?
X equals 3 and x equals negative 1.
Awesome.
X equals 4 and x equals negative 2.
How many solutions did we expect? 4. Okay, last type. And we can practice some more next time if we need to. Last one. I promise for now. We still have 2 more down the road, exponential and logarithmic equations. But there is nothing else. Okay, it's a long list, but we're done. 2 more in chapter 4. Okay, so these are absolute value equations. Equations that have absolute value in them. Before we look at a couple of examples, I just want to refresh your memory on how to address this. Let's look at a very simple situation. The absolute value of x equals 9. What does this say? It says find x values that are exactly how many units from 0?
9.
9 units, very good, from 0. So imagine 0 in the middle. How many solutions will I have? How many numbers that are exactly 9 units away from 0?
2.
Right, and they are?
9 and negative 9.
9 and negative 9. 2 options. X equals 9, x equals negative 9. Let's check. We don't have to, but I just want to make a point. So what is the absolute value of negative 9?
9.
What is the absolute value of 9?
9.
That's it. So let's look at a couple on the same page, 186. Let's look at 72. 4. The absolute value of 1 minus 3/4 x plus 7 equals 10. You can say, wow, from this little equation, look what you are looking at now. Yes, indeed. A lot of work. So my first step, one note, is we have 2 keywords that we should always have on our minds.
You're factoring and simplifying.
Correct. So obviously, I have to simplify this to make it look like this. This is how I know how to solve. This needs some steps, right? There are some steps in there. So I have to simplify this to make it look like this. Not just necessarily just x, but the expression with x, absolute value, 1 in front, and the number on the other side. Because I can change this. The other note that we have to always remember the absolute value cannot be touched, quote unquote, meaning the absolute value symbols are not a grouping symbol. You cannot distribute 4 inside. You cannot take anything outside. This has to stay as is forever. You can't do anything to it. Okay? So, one more time, 2 steps. Clean it up, I like to say, or simplify it to look like this. And number 2, you cannot distribute or take anything out from the absolute value. There are 2 properties that we don't of the absolute value that we don't discuss in this class. So for now, we just have to remember no one can break the absolute value in any way, shape, or form. Okay, so what will be the first step towards simplifying this? Of course. Absolutely, I have to subtract 7 from both sides. And the final step of simplification is, this is multiplied, I cannot, perfect. So 1 minus 3/4 x equals 3/4. Excellent. I'm done simplifying. There is nothing else I can do. I cannot move anything to the other side. I cannot break the absolute value. The only thing I can do is remember what the options are. This particular quantity could be 9 or negative 9. What could this particular quantity be?
3/4.
Or,
Negative 3/4.
that's it. There is nothing else I can do. This cannot be solved unless I know how to present these 2 equations that make up this one. Now, these equations are linear. There is no difficulty here. We can eliminate the denominator first if you want, and then find x. And this is it. That's the end of equations, and we'll look at another example. So let's solve this one. 1 minus 3/4 x equals 3/4. We can eliminate fractions right away, multiplying all terms, both sides, slowly by, good. How much is 1 times 4?
4.
How much is negative 3/4 times 4 over 1? These go away.
3.
Minus 3x. The same thing here, equals 3. So one more time. Simplify before you multiply. So negative 3x equals negative 1, so x equals 1/3. I solved the exact same thing, same steps, but this time with minus. So you can copy it from here, but with minus. I can write 4 minus 3x equals negative 3. Because I already did the multiplication by 4. So the only difference is the sign. Everything is the same, just the sign here. So now negative 3x equals negative 7, so x equals, 7/3. We don't need to go back and check unless we want to. Any questions? Any questions? Okay, so let's look at another, and you please walk me through the next one. Let's say 66. And this is 2x minus 3 in absolute value equals 11. Is this fully simplified?
Yeah.
Yes. So I can go ahead and replace it by, remember you cannot, don't cross it out like that, I'm just making a point, you cannot touch that. If we don't remember that it translates into 2 different equations, we cannot solve. We cannot remove the absolute value, we cannot do anything here. But we know that it changes into 2 different equations, and they are.
2x minus 3 equals 11.
Excellent.
2x minus 3 equals negative 4.
Good. I move 3 to the other side, so I get 2x equals 14. So I get an x, which is 7. I move 3 to the other side, and I get 2x equals negative 8, so I get x equals negative 4. last section of chapter 1. This was a lot of review from previous classes. So let's make a list, a complete list of equations that we know now. Help me make a complete list. First one we looked at. Very good. Next one we looked at. Very good, awesome. Next one we looked at. Very good. Next one. Awesome. Next one. Radical. Next one. With rational exponents.
I don't know.
With the one with 3 halves or
Was there like not a name for it? It's just with
it's still radical, but we want to differentiate because it has 2 steps. First I eliminate the denominator and then I eliminate the numerator.
Okay.
Quadratic in form. And the last one that we just completed, absolute value. 2, 4, 6, 8. 8 different ones. They have different strategies. We have to understand and remember each strategy. Okay? Good. So now the last section, 1.7. Absolute inequalities, linear inequalities, and absolute value inequalities. 1.7. Linear and absolute value inequalities. Linear and absolute value inequalities. Let's start with linear. I'm going to copy an example. Let's say on page 203. Let's start with problem 38, in which we have -4, quantity x plus 2 greater than 3x plus 20. Before we attempt this problem, I just want to refresh our memory on interval notation. So if I have x greater than or equal to 2, the interval notation will be 2 with a bracket to infinity. If I have -1 less than x less than or equal to 3, what will that interval notation be? When we don't have the equal symbol, parenthesis, -1, comma, 3 with a,
bracket.
very good. So these go together. Good. So what will be the first step? Exactly the initial steps are the same with a linear equation. I cannot change it into an equation, but the steps are similar. So what would be my first concern here? Distribute. -4x minus 8 greater than 3x plus 20. I recommend, but not enforce, the variable on the left. It's up to you. I will move 3x, I will move -8. If we do that, what do we have on the left-hand side? Remember, we bring the opposite sign. Perfect. -7x greater than 28. Excellent. We need to divide now both sides by. Good. So I divide by -7. I get x on this side. I get -4 on the other. However, yes, we have to flip the sign. Do we remember that we have to flip the sign? Yes, when we divide or multiply. Let me explain why. Here's an explanation for that. Is 2 less than 10? Let's say for whatever reason we want to multiply both sides by -1. I have -2 and -10. Which one is bigger now?
-2.
-2. So this happens every time we multiply or divide both sides of an inequality by a negative number, not by a positive. In interval notation, we start from left to right. So this interval is, if you want to picture it, I don't need units here. I'm not going to ever use units. So let's say this is -4. So it's this side. In some books, maybe in your book too, they use an open point, which is fine too. I prefer a parenthesis because that's what I need to write. So then the interval notation, can anyone give us the interval notation for the solution? X, I say in the interval, parenthesis, comma, with a bracket or parenthesis? Correct, because there is no equal sign. I don't want to start the absolute value inequalities today because I would like to explain both together. So let's choose another linear equation inequality and then we can stop. I know I have 4 minutes left. 46. Any questions before we look at 46 on page 203? Okay, 4x minus 3 divided by 6 plus 2 greater than or equal to 2x minus 1 over 12. We had a similar example with linear equations. What did we do? If you remember what we did when we solved something like this, but it was an equation, not an inequality. We eliminated we found the least common denominator in order to eliminate all denominators. So what will I multiply everything by? Not the greatest common factor, but the least common denominator. The least common denominator is the smallest number that is divisible by 6, by 1, and by 12. The smallest number that is divisible by 6, 1, and 12. Divisible. Not greatest common factor. So let's not confuse the two. Let's talk about this because this is more important. The least common denominator, also called the least common multiple, is one thing. And the greatest common factor is a totally different thing. Yes, correct. So if I have 6, 1, and 12, I'm looking to find the smallest number that is divisible by 6, is divisible by 1, and is divisible by 12. Now, if I have 6, 1, and 12, and want to find the greatest common factor, maybe I shouldn't even put the 1 in there because then I will not have a common factor, right? So if I have these two, only these two, I'm going to erase the 1. So what is the greatest common factor of x and 12? The concept is, what is the biggest number that 6 and 12 can be divided by? So one more time, this is the smallest number that can be divided by 6, 1, and 12. This one is the largest number that 6 is divisible by and 12 is divisible by. That's why this one is 6. And let me erase the 1, because otherwise there is no greatest common factor there. Okay, so the greatest common factor is 6, and the least common denominator is 12. Okay, so then we multiply the first fraction by 12 over 1, the second fraction just by 12, and this last one by 12 over 1 because I want to simplify before I rewrite. That's the easiest thing to do. Divide by 6, divide by 6. Divide by 12, divide by 12. What is left from this first fraction? There is a 2. The denominator is 1. 2 multiplied by 4x minus 3. Do you all see that? What is left from the second one is 2 times 12, so plus 24. What is left from the last one? Greater than or equal to 2x minus 1. I know I have 6:15. If you want us to stop here, we can stop and finish it later, or we can finish it now. It's up to you. Okay, thank you. As a courtesy to you, I have to ask. So then we have 8x minus 6 plus 24 greater than or equal to 2x minus 1. We had to distribute and eliminate parentheses. So now, always combine like terms first. Plus 18 greater than or equal to 2x minus 1. So now I move terms around after I simplified both sides. So I move 2x and I move 18. When I move terms from one side to the other, I change the sign. So when I move 2x, I have 8x minus 2x. What is left on the left? And then I bring an 18, but I have to change its sign, so it's negative 19. As the final step, I will divide both sides by 6, and I get this. Now in interval notation, I hope that you will not have to present the real line all the time, but if you want to. Negative 19, no units, I don't care for units. Negative 19, 6 is somewhere here, and then I have to go to the right-hand side to infinity. So in interval notation, x is in the interval bracket negative 19, 6, comma, infinity. Now if it's